everyone, and now I will discuss the three contributions of mathematics in the field. First, Friedrich Karl Gauss. Second, Jan Wien. Third, Claude Shannon. First, Carl Friedrich Gauss, born on April 30, 1777, Brunswick, Germany. Died February 23, 1855, in Göttingen, Hanover. German mathematicians, generally regarded as one of the greatest mathematicians of all time for his contribution to the number theory. Number theory is the study of the set positive whole numbers. Geometry. Geometry is with arithmetic, one of the oldest branches of mathematics. Probability theory. Probability theory is the branch of mathematics concerned with probability. Geodesy. Geodesy is the earth science of accurately measuring and understanding Earth's geometric shape, orientation in shape, and gravitational field. Planetary astronomy. The theory of functions. A theory of functions of a real variable. The traditional name of real analysis, a branch of mathematical analysis dealing with the real numbers and real value functions of a real variable. The function that associates any of the four colored shapes to its colors. And potential theory, including electromagnetism. Gauss was the only child of poor parents. He was rare among mathematicians in that he was a calculating prodigy, and he retained the ability to do elaborate calculations in his head most of his life. Impressed by this ability, by his gift for languages, his teachers, and his devoted mother recommended him to the Duke of Brunswick in 1791, who granted him financial assistance to continue his education, and also he studied mathematics at the University of Göttingen 1795 to 1798. Gauss' pioneering work gradually to establish him as the era's preeminent mathematicians, first in German-speaking world and then further afield. Although he remained a remote and loved figure, Carl Friedrich Gauss was a prominent figure in the 19th century in Germany for his accomplishment in the disciplines of mathematics. He is known for his monumental contributions to statistics, algebra, differential geometry, mechanics, astronomy, and number theory, among other fields. Those who regard his work very highly often refer to him as greatest mathematicians. Since antiquity and in Latin precepts, Mathematicum, the foremost of mathematicians. After Gauss' death in 1855, the discovery of many novel ideas among his unpublished papers extended his influence into the remainder of the century. Gauss' first significant discovery in 1792 was that a regular polygon of 17 sides can be constructed by ruler and compass alone. His doctoral thesis of 1797 gave a proof of the fundamental theorem of algebra. Every polynomial equation with real or complex coefficient has many-root solution as its degree. The highest power of the variable, Gauss's proof, though not wholly convincing, was remarkable for its critique of earlier attempts. Gauss's recognition as a truly remarkable talent, though, resulted from two major publications in 1801. Foremost was his publication of the first systematic textbook on algebraic number theory, the Codes of Carl Friedrich Gauss. Mathematics is the queen of the science. Mathematical discoveries, like springtime violets in the woods, have their season which no human can hasten or restart. Example of guest like circular cylinder and a flat sheet of paper have the same, and flat sheet of paper have the same intrinsic curvature, which is why exact copies of figures on the cylinder can be made on the paper, as for example in painting. But a sphere and a plane have different curvature, which is why no completely accurate flat map of the earth can be made. Yes, published works on number theory of map constructions and many other subjects. Also wrote on cartography, the theory of map projection. For his study of angle preserving maps, he was awarded the prize of the Danish Academy of Science in 1823. And now, number 2, the contributions of Jan Veen. Jan Veen was a mathematician remembered best for his contributions to the study of mathematical logic and probability. Ben was born in England in 1834 and studied at Cambridge University until 1857. He was ordained as a priest in 1859 and served as a curate for a year before returning to Cambridge to lecture on moral science. While at Cambridge, Ben spent his time both teaching and studying probability theory and logic. He developed a method of using diagrams to illustrate set theory called Venn diagrams. Typically, Venn diagrams use overlapping circles to present groups of items or ideas that their common properties. Each circle presents one property, and shared properties are represented by the overlapping areas of the circles. For example, according to him, suppose you see 3 overlapping circles like A, B, and C to represent 4 legged animals, domesticated animals, and predatory animals respectively. From this diagram, you could start to see how the overlapping categories create different sets. Letter A, for cat, for example, would fall a set represented by the overlap of A, B, and C. A horse, however, would fall in the set shown by the overlap between A and B, only not C, although they have many application Venn diagram. Also aim in the study of Boolean logic, another type of logic named after the 19th century mathematician George Boole. In 1866, Venn wrote Logic of Chance, a work that was considered a highly original and influential on the development of the theory of statistics. He also wrote Symbolic Logic in 1881 and Principles of Empirical Logic in 1889. In 1881, he was elected a member of the Royal Society for his work in math and logic. So, later in his life, however, Venn turned to interests outside of mathematics. He began compiling a history of Cambridge University, of which he completed 3 volumes. He also had a talent for building machines and invented on that automatically boiled cricket volley. Venn lived until 1923. That's all.
Shannon was born in Fetoski, Michigan on April 30, 1916. He graduated from the University of Michigan in 1936 with bachelor degrees in mathematics and electrical engineering. In 1940, he earned both master's degree in electrical engineering and Doctor of Philosophy in mathematics from Massachusetts Institute of Technology. His work founded the subject of information theory. Claude Shannon died in February 2001.
According to him, there are sharing of knowledge, the place to gain and share knowledge, empowering people to learn from others and better understand the world. According to Claude Shannon.
The contribution of Claude Shannon, 1916-2001, famous for having founded information theory in 1948, the digital computer digital circuit design theory in 1937, demonstrates that electrical applications of Boolean algebra could construct or resolve any logical numerical relationship. It has been claimed that this was the most important master's thesis of all the time.
He is unknown to many of us today, but Claude Shannon, he is the reason that you can read these words on the screen. Because Claude Shannon, he is the father of the information age. And he learned that title because of the work that he did in 1930s and 1940s that helped to lay the groundwork for the digital world. Now, we live in a world that takes it for granted that all you need to do in our mostly complex logical operations are a series. This has been called the Magna Carta of Information Age, meaning a fundamental document for the age